Welcome students to online classes of mathematics for class 8. In this video we are going to study chapter number 7, which is the cubes and the cube roots of NCERT textbook, and we will be covering the exercise 7.1. This is the session number 1 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The topic that we are going to study today is the cubes. Okay, so you must have heard about the cubes in your previous classes. In geometry, simply a cube is a solid figure which has all its sides equal. Solid figure means it's a three-dimensional figure. Okay, when you say it's a solid figure, that means you're talking about us three-dimensional shapes. Okay, all the three-dimensional shapes, like we have the cube, cuboid, cylinder, cone, sphere, all of them are solid figure. Okay, so if you are talking about the solid figure, that means we are talking about the three-dimensional figure. So in geometry, simply a cube is a solid figure which has all its sides equal. You can see this is the general diagram or the shape of a cube. Okay, so in this cube all the sides are equal. Let's say this side is a, which is the length, this breadth is also a, and the height is also a. As I said, it's all sides are equal. Okay, so we have its length a, breadth a, and also the height as a. So if we find the volume of this cuboid, that is volume of, not cuboid, cube. So the volume of cube will be given by side into side into side. That is, first side is a, length is also a, breadth is also a, and height is also a. So this will give us a power 3. Okay, so this power 3 is called the cube. So we can read this as a cube. Okay, so that's what we are going to study here, that the power 3 of any number is called the cube of that number. You must have seen a number like this. If we multiply 1 into 1 into 1 3 times, that means 1 into 1 into 1, you will get 1 into 1 is 1, again 1 into 1 is 1, that is 1, or we can write this one as 1 cube. Okay, so we have, if you multiply 2 into 2 into 2, so you will get 2 into 2 is 4, 4 into 2 is 8, or we can write this 8 as 3 times 2. Okay, that is 2 cube. Or if you write 3 into 3 into 3, 3 into 3 is 9, 9 into 3 is 27, or we can write 27 as 3 power 3, that is 3 cube. Or let's see another number, 4 into 4 into 4, 4 into 4 is 16, 16 into 4 is 64. Okay, that means we can write 64 as 4 cube. Similarly, if you have a number, let's say 5 into 5 into 5, so 5 into 5 is 25, 25 into 5 is 125, or we can write this 125 as 5 cube. Okay, so these 1, 8, 27, 64, 25, and so on, these numbers are called perfect cube or cube numbers. Okay, so I'll write the numbers 1, 8, 27, 64, 125, and so on are called perfect cube or cube number. These are called perfect cubes or cube numbers. Okay, so these are the number obtained by multiplying 1 into 1, 2 into 2 into 2, 3 into 3 into 3, 4 into 4 into 4, and 5 into 5 into 5. Okay, so number that we got is 1, 8, 27, 64, and 125. And if you multiply the other next number, that is 6 into 6 into 6, and so on, you will get the numbers, and all such numbers are called perfect cube or cube numbers. Okay, these are the number obtained by a number by itself 3 times. Okay, like we did in the square, we are multiplying the number 2 times and we are getting the square. Okay, here we are multiplying the number 3 times, we are getting cube of each number. Okay, I have shown you a table here. So the cube, we have a number 1, cube of 1 is equals to 1. We have number 2, cube of 2 is 8, 3, cube of 3 is 27, we have 4, 4 cube is 64, 5 cube is 125, 6 cube is 116. 7 cube is 343. 8 cube is 512. 9 cube is 729. And 10 cube is 1000. Okay, so these are the cubes of the number 1 to 10. And similarly we have the cube of 11 is 1331. Cube of 12 is 1728. Cube of 13 is 2197, and so on. Similarly the cube of 2 is 8000. Okay, so from here you will notice that we are getting all the numbers at the unit place. Let's see, from here we are having 0, 1, 2, 3, 4, 5, 6, 7, 7, 8 and 9. That means all the number that is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the numbers are appearing at the unit place. So by looking at the numbers we cannot decide whether this number will be a perfect cube or not, like we used to do that in the square number. Okay, in case of square number, if number is given, you can easily identify whether this number will be a square number or not, like because there we have few numbers which may appear at the first unit place, and there are some number which will never appear at the unit place while in the square numbers. Okay, but in the case of cubes you will have all the digits, that is 0 to 9 at the unit place for different numbers. Okay, so by looking at the number we cannot identify whether this number will be a perfect cube or not. Okay, so I have written this, the cube of number 1 to 10 here, and 1 to 11 to 20 here. You have to memorize all these cube number. Okay, that will help you in solving the question, and also it will save your time. Okay, so memorize all these cube numbers at least from 1 to 20. Okay, I'm moving ahead. Next is some interesting patterns in cube numbers. Okay, you can write some interesting patterns in cube numbers. Okay, the first pattern that we have, adding consecutive odd numbers. Okay, like we used to do in the case of square number. I'm writing that here just to recall that in square number, if we add, we take one first odd number, that is 1. 1 is equals to 1, and which is the square of 1. If you add the two consecutive odd numbers, that is 1 and 3, so the sum of 1 and 3 is 4, and 4 is the square of 2. Okay, similarly if we add three consecutive number, that is 1 plus 3 plus 5, 1 plus 3 plus 5 is 9, and 9 is, sorry, this is 8. 9 is the square of 3. Okay, if you add 1 plus 3 plus 5 plus 7, the sum of these four number is 16, and 16 is the square of 4. Okay, if you add next 5, if you add first 5 odd number, that is 1 plus 3 plus 5 plus 7 plus 9, their sum is 25, and which is the square of 5. So if you add 5 numbers, you will get the square of 5. If you add 4 numbers, you will get square of 4. If you add 3 number, you will get square of 3, and if you add 2, you will get square of 2. If you keep 1, you will get the square of 1. Okay, in similar way, in the case of cube number, we have, if you take first odd number, 1 is equals to 1, which is the cube of 1. So here we will not take the first, in the next step we will not take the first two cube number, we will take next two. After 1, the next two cube number are, or next two odd numbers are 3 and 5. The sum of 3 and 5 is 8. 8 is the cube of 2. Okay, after 2 we'll take next three odd number, that is 7, 9 and 11. The sum of 7 and 11 is 27, which is the cube of 3. Okay, after 11 we'll take next four odd numbers. So after 11 we have 13, 15, 17 and 19, and the sum of all these four number is 64, which is the cube of 4. Okay, then we have the cube. After 19 we have the next 5 odd number, which are 21, 23, 25, 27, 29. When you add these all, you will get 125, which is the cube of number 3. Okay, can you now differentiate between the two? In the case of square number, we are adding first odd number, that is first. In case of first one, we have first odd number, which is 1. For 2 we have first two odd number. For 3 we have first 3 odd number, first 4 odd number, and first 5. But in case of cubes, we'll take first number. After that we have next two cube number, which is 3 and 5. After this step we'll have next three odd number, that is 7, 9 and 11. Okay, after 7 and 11 in next case we'll take next 4. Okay, so we are not repeating the number here, while here we are repeating the number. We have 1 here, here, here and every time, but here once 1 is taken, will not take that again, we'll put to the next two odd numbers. Okay, so in case of 1 we are adding 1, in case of 2 we are adding 2, in case of 3 we are adding 3 consecutive odd number, in case of 4 we are adding 4 consecutive odd number, and in case of 5 we are adding 5 consecutive odd numbers. Okay, this is the one pattern in the cube numbers. Okay, now moving ahead, we have next topic is cubes, and this should be and cubes and their prime factors. Okay, so next topic that we are going to study is cubes and the prime factor. Suppose we have a number, let's say 27. And we are to find the prime factors of this number. So write the number here, let's divide this by the prime number. So we have this is not divisible by 2, so we have first prime number that will divide this is 3. So when you divide 27 by 3 you will get 9, again dividing by 3 you will get 3, again dividing by 3 you will get 1. Okay, so we'll stop here. So the prime factors of 27 will be 3 into 3 into 3. Okay, that's 3 into 3 is 9, and 9 into 3 is again 27. So you'll see that we are getting a triplet of number 3. So in case of cube numbers you will always get the triplet of the prime factors. Okay, if you're not getting a triplet of prime factor, then it means it will not be a perfect cube. Okay, so we can write 27 as cube of 3. Okay, let's take a higher number or a bigger number. Okay, I'm going to take, let's now 1331. Okay, we'll find if this is square of any number, sorry, cube of any number. So write the number here, let's find its prime factor. This number is divisible by 11. So when you divide this by 11 you will get 1 here, the carry will be 2, so you'll get 2 here, which is 11 into 2 is 22, carry will be 1, so 11 into 1 is 1, so we'll get 121. This 121 is again divisible by 11, so we'll get 11 here, again dividing by 11 we'll get 1. So we can write 1331 is equals to 11 into 11 into 11. Okay, which is the cube of 11. Okay, that's how we find the prime factors. Or if it given number is a cube number or a perfect cube number, you will always get the triplet of the prime numbers. Okay, let's take another number which is not a perfect cube number. Let's say take 90. Okay, we know that we have this 64 which is the cube of 4, then after that we have 125 which is cube of 5. So 90 is lying between these two, and which is not a perfect cube number. So this 90, we know that's not a perfect cube number. Let's find its prime factor to check or verify. We have 90 here, so 90 is the odd even number, so we can divide it by 2, so we'll get 45 here. Now this cannot be divided by 2 further, so we'll divide it by 3, get 15, again divided by 3 we'll get 5, and again now we have to divide by 5, we'll get 1. Okay, so the prime factors of 90 are 2 into 3 into 3 into 5. So clearly you can see we are not getting a triplet of either number 2, we are not getting a triplet of either number 2, number 3 or number 5. Okay, since we are not getting triplet of any of the prime factors, so this number is not a perfect cube number. Okay, so what if we are to make it a perfect cube number? So to make it a perfect cube number we need to multiply. We already have this 2 into 3 into 3 into 5. So to make it a perfect cube number, what we have to do is we have to make a triplet of 2. That means we have to multiply 2 into 2. Okay, since we already have 1 time 2, so we'll multiply 2 more times 2. Here the 3 is 1 and 2, so we need one more 3 to make it a triplet. And for 5 we have only one 5 here one time, so we need to multiply it by 2 times 5s. Okay, so this will be the multiplication of these is 90. Let's find the multiplication of these. 22 is 4, 4 into 3 is 12, 12 into 5 is 60, and 60 into 5 is 300. Okay, so when you multiply these two, 9 into 3 is 2700. Okay, this 27,000 is the cube of, this is a cube of 30. Okay, so in order to make this 90 a perfect cube number, we need to multiply this by this much digit, is 300. Okay, or there can be a one question to make it a perfect cube number, by which number should be divided. So we have to divide this number by 190, this number by 90. Okay, when you divide this by 90, the result will be 1, and 1 is a perfect cube number. Okay, so you will understand this better when we'll do the exercise. Okay, now let's move to the exercise 7.1. Here in this exercise we have total 4 questions. We'll do all 4 in this session. So the first question is, which of the following numbers are not perfect cube? Like I said, by looking at the numbers we cannot identify whether it's a perfect cube or not. Okay, like we used to do in the case of square number. Okay, but in case of cube number we have to verify by finding its prime factors. Okay, so we have this first question. It has 5 parts. I will do the 3 of them, that is first, third and fifth. Okay, remaining 2 will be done by you. So let's start with the part 1 of question number 1. The number given to us is 216. So we are now going to find its prime factors. So write the number here, 216. Right, draw this line. Okay, now we have to divide this. We get this 216 is a even number, so we can divide this by 2. So we'll get 108. Now again dividing this number by 2, we'll get 54. Again dividing by 2, we'll get 27. Now this cannot be divided by 2, so we'll divide this by now 3, so we'll get 9. Again dividing by 3, we'll get 3, and again dividing by 3, we'll get 1. Okay, so the prime factors of 216 is, the prime factors of 216 is, so we'll write 216 equals to 2 into 2 into 2 into 3 into 3 into 3. Okay, so now we are getting here the triplet of number 2 and also triplet of number 3. So we can write this number as 2 into 3. We are taking in one number from here and one number from here, and out we'll write the whole power 3. Okay, so this 2 into 3 is 6, and outside power we have 3. So this 216 is equals to 6 cube. That means this is a perfect cube number. Okay, so the moment you get this, the pair of triplet of all 3, triplet of all the prime number, that means it will be a perfect cube number. Okay, so we'll write, since in the prime factors of 216 we are getting the triplets of 2 and 3, or you can have triplets of prime number 2 and 3, triplets of prime number 2 and 3, hence it is a perfect cube number. Okay, the moment you get the triplet of each prime number, that will be a perfect cube number. Okay, so let's see the now the part 3. We have the number 1000. Number given to us is now 1000. Let's find its prime factors. Write the number here, find its prime factor. We first by making line here, Let's divide this number by 2, we'll get 500. Again divided by 2 we'll get 250. Again divided by 2 we'll get 125. Now this can be divided by 2 and also not by 3, so we'll divide this by now 5. So we'll get 525 here. Again divided by 5 we'll get 5, and one more time divided by 5 we'll get 1. So okay, we'll stop here. So write the prime factors of 1000 is, so write 1000 equals to, we have 3 times 2 and 3 times 5, so 2 into 2 into 2 into 5 into 5 into 5. Okay, now you can see we are getting one triplet of number 2 and also a triplet of number 5. So write, since in the prime factors of 1000 we are getting the triplet of number of prime number 2 and 5, hence it is a perfect cube number. Okay, so that's the answer of the part third of question number 1. Now moving to the next and the last part of this question, which is part number 5. We have the number 46656. Okay, 46656. so now we have to find its prime factor. Let's write the number here. We have 46656. okay, this is 46,656. so let's start by finding its prime factors. Okay, as it is a even number, so we'll divide this first by 2, so we'll get 2 3 3 2 and 8. Okay, again dividing by 2 we'll get 1 1 6 6 4. Okay, again dividing by 3 we'll get 5 8 3 2. Okay, again dividing by 2 we'll get, okay, we'll get 2 9 1 6. now again dividing by 2 we'll get 1 4 5 and 8. Okay, again dividing this by 2 we'll get 7 2 9. Okay, now this cannot be divided by 2 now, so we'll divide this by now 3. so dividing by 3 we'll get 2 4 3. again by 2 we'll get 8 1. Okay, let's move ahead. Dividing by 3 we'll get 27. again dividing by 3 we get 9. again dividing by 3 we'll get 3, and one more time dividing by 3 we'll get 1. now you can see we are getting a triplet of number 2 here, another triplet of number 2, one triplet of 3, and another triplet of number 3. So since we are getting the triplet of each number here, so this will be a perfect cube number. Okay, let's write the prime factors of 46,656 is, so write the number 46656 is equals to, we have 6 times 2, so it is 1 2 3 4 5 6. then we have 6 times 3, that is 1 2 3 4 5 6. okay, so you can see we are getting a pair of number 2, also triplet of number 2, another triplet of number 3, and a triplet of number 3. so right, since in the prime factors of 46,656 we are getting the triplet of number, we are getting a triplet of number 2 and 3. Hence, the given number is perfect cube. Okay, so that's the answer of the question number 1, and we have done the part 3. The remaining 2, the second and fourth will be done by you. Okay, now moving to the next question, we have the question number 2, in which find the smallest number by which each of the following number must be multiplied to obtain a perfect cube. So we have to, you are given a number, some numbers, so we'll find their again prime factors. If it is a perfect cube, then it's okay. If it's not a perfect cube, we need to find a number which should be multiplied to this given number to make it a perfect cube. Okay, so let's start with the first one. Again, I will do here only two parts, that is first and the fourth. Okay, remaining will be done by you. So that's the answer number 2. The number first we have 243. So first let's find the prime factors of the number 243. Okay, let's divide this by 3, we'll get 8. 1 again divided by 3 will get 27. Again divided by 3 will get 9. Again divided by 3 will get 3, and one more time divided by 3 will get 1. So right, the prime factors of 243 is, the prime factor of 243 is, so write 243 equals to, we have 1 2 3 4 5 times 3, so 1 2 3 4 and 5 times 3. Okay, now you can notice here we are getting a triplet of number 3 and a pair of number 3. We are getting a triplet and a pair of number 3, so we are not getting a triplet here. That means this number is not a perfect cube. So by which number should we multiply? Since we already have 2 times 2, we need 1 more time 2 to make it a perfect cube. Okay, so we need to multiply 1 more time 3 to to get a triplet of number 3. Okay, another number of triplet of number 3, so this number needs to be multiplied by 3. So we'll write, since in the prime factors of, since in the prime factors of 243 we are not getting the triplet of prime number 3, therefore we need to multiply the given number by 3 to make it a perfect cube number. Okay, so that's the answer of the part 1 of question number 2. I will do the now part 4, which is 467. So 6 with the number is given to is 675. Okay, the number we have now is 675. Again, let's find its prime factor. 675, as we have the 5 at the ones place, so we'll directly divide number by 5, so we'll get 1 3 and 5. Again dividing this 5 will get 2 7. Now divided by 3 will get 9. Again divided by 3 will get 3. Again divided by 3 will get 1. So like the prime factors of 675 is equals is, so write this here, 675 equals to, we have 2 times 5, that is 5 into 5, and 3 times 3 into 3. Now clearly you can see that here we are getting a triplet of number 3, but we are not getting a triplet of number 5. Okay, you can see here we are getting a triplet of number 3, but we are not getting triplet of number 5. So this number will not be a perfect cube number. So in order to make it a perfect cube number, we need to multiply this number by 5, so that we'll get a triplet of number 5 also. Okay, okay, so right, since in the prime factors of since in the prime factors of in the prime factors of 675, we are not getting the triplet of prime number 5. Therefore the given number needs to be multiplied by 5 to make it a perfect cube. Okay, so if you multiply the given number of 5, it will be a perfect cube then. So that's the answer of question number 2. Remaining will be done by you. This was the part 6, not 6, 4. Okay, this was the part 4. Now moving ahead to the next question. Question number 3, again we are asked, find the smallest number by which number each of the following number must be divided to obtain a perfect cube. Okay, now in the question number 2 you are asked by which it should be multiplied. Now you are asked by which the given number should be divided to make it a perfect cube number. Okay, in this I will do the second and the fifth. Remaining will be done by you. So let's try the answer number 3, part second. We have number 128. Let's find its prime factor first. So write the number 128. So since it is an even number, so we'll divide this first by 2. You will get 6. 4 again divided by 2 will get 32. Again dividing by 2 will get 16. Again dividing by 2 will get 8. Then 4, and again dividing by 2 will get 2, and one more last time we'll get 1 here. So now you can see we are getting a triplet of number 2, another triplet of number 2, but we are having a single number 2. So write the prime factors of 128 is, so 128 is equals to 2 into 2 into 2, again 2 into 2 into 2, and one more time 2. So total we have one triplet of 2, another triplet of 2, and a single digit 2. So if we multiply this given number by this, the number of which we are not getting a triplet, this will become a perfect cube number. Okay, so we'll write, since in the prime factors of the prime factors of 128 we are not getting triplet of number 2, so we need to divide the given number by 2 to make it a perfect cube number. Okay, so since we are not getting a triplet of this number, so if you divide the given number by this 2, you will get a triplet of 2 and another triplet of 2, so this will be a perfect cube number. So the number by which it needs to be multiplied is 2. Okay, that's the our answer. So now moving ahead to the next part, let's see the part 5. The number is 704. It is 704. Let's find first its prime factor. So write 704. Okay, since this number is a even number, so we'll start this by dividing by 2, so we'll get 3 5 2. Again divided by 2, we'll get 1 7 6. Again divided by 2, we'll get 8 8. Now again divided by 2, we'll get here 4 and 4. Okay, this again divided by 2 will get 22. Again divided by 2 will get 11. Okay, now we'll divide this by 11, so we'll get 1. So right here you can see that we are getting a triplet of number 2, another triplet of number 2, and a single digit or single number 11. Okay, so that's the prime factors of the prime factors of 701 is 704 is equals to 2 into 2 into 2 into 2 into 2 into 2. So we have 6 times 2 and then 11. Okay, so clearly you can notice here that we are getting a triplet of number 2, another triplet of number 2, but we are not getting a triplet of number 11 here. So this number need to be multiplied by 11 to make it a perfect cube number. So right, since in the prime factors of 704 we are not getting the triplet of prime number 7, so we need to divide this given number by 7 to make it a perfect cube, to make it a perfect cube number. So the answer for this question is we need to divide this number by 7. Okay, we need to divide this number by 7 to make it a perfect cube number. That's the answer of the question number 3 part 5. Okay, now let's see the last question of this exercise, which is the question number 4. It says Parikshit makes a cuboid of plasticine of side 5 cm, 2 cm and 5 cm. How many such cuboid will he needed to form a cube? Okay, so Parikshit have a cuboid of plasticine which has a dimension 5 into 2 into 2. So length is 5, breadth is 2 and height is also 5. We need to find how many such cuboid will he need to form a cube. Okay, so we'll write answer number 4. The dimensions of cuboid are 5 cm, 2 cm and 5 cm. Okay, so we know that the volume of a cuboid is given by, we know that the volume of cuboid is given by L, that is length, into B, which is breadth, into H, that is height. Okay, that is length here is 5, breadth is 2 and height is 5. So we're getting a number here 50 centimeter cube. So this is the volume of one cuboid. We need to find how many such cuboid are needed to make it a perfect cube number. You will see, notice that this 50 is not a perfect cube number. So because before 50 we have a perfect cube number which is 27, which is cube of 3, and after 50 we have a perfect cube number which is 64, which is the cube of 4. Okay, so this 50 is lying between 27 and 64, so this 50 is not a perfect cube number. So now, and the multiplication of this number will give us the prime factors of this number 50. So in this prime factor, you will notice that we are not getting the triplet of either number 2 or number 5. So right, since in the prime factors of the volume of cuboid, since in the prime factors of volume of cuboid, so let's, since in the prime factors of volume of cuboid, we are not getting the triplet of number of prime number 2 and 5, and so we need to multiply the given number by, so given number by, now you can see we are here, we are having a pair of number 5, so we need one more time 5, and we are having only single digit 2, so we need 2 times 2. So these are the number by which it should be multiplied. So we'll write, so we need to multiply the given number by 5 into 2 into 2, okay, to make it 5 into 2 into 2, which is 20, to make it a perfect cube number. Okay, so we need to multiply the volume of one cuboid by 20 to make it a perfect cube number. Okay, therefore the answer is, he required 20 more such cuboids to make it a perfect cube number. Okay, so that's the answer of question number 4 of exercise 7.1. okay, with this we have finished all the question of exercise 7.1. I hope you understood all the question. All of them are very easy, just you have to find the prime factors and you have to see if you are getting a triplet of a number or not. If you are getting a triplet, that means a perfect cube number. If you are not getting a triplet, then it's not a perfect cube number. okay, जिस भी नंबर का ट्रिपलेट फॉर्म नहीं हो रहा, अगर उससे मल्टीप्लाई कर दें कि ट्रिपलेट बनाने के लिए, देन इट विल बी परफेक्ट क्यूब, या जो भी एक्स्ट्रा नंबर है जिसका ट्रिपलेट नहीं बनना उसको हम डिवाइड कर दें, तो अगेन इट विल बी अ परफेक्ट क्यूब नंबर. ओके, so that's how what we have done in all the questions. okay, I hope you understood. So that's all for now. Thanks for joining here.